So we've got all of our limit laws. Let's look here at example 2 so that we can work these examples and see exactly how this all plays out. So I'm told that the limit as x approaches 2 of f of x is equal to 4. And the limit as x approaches 2 of g of x is equal to 5. And the limit as x approaches 2 of h of x is equal to 8. So with this, I want to determine the limit as x approaches 2 of f of x minus g of x over h of x. Yeah, exactly. You literally plug it in. So the limit as x approaches 2 of f of x, that's 4. So this piece is a 4. The limit as x approaches 2 of g of x is 5. So the limit as x approaches 2 here of g of x is 5. So I'm subtracting 5. The limit as f of x, or pardon me, the limit as x approaches 2 of h of x is going to be a 2. So you get negative 1/2. All right. In this instance, they're telling you what it is. So then you work that out. And it is the same thing for all of it. You just plug that in. Now, I'm going to show you this here just so that you have a reference of what's going on. Your book, and if you do help me solve this, is going to show you stuff like this. Can you see that? So see how they're saying, oh, take this, break it up, break it up, break it up. We're not going to do that. Oh, I did the wrong thing. Look at that. See, good thing we checked this out. You're probably looking at that going, wait. I put that 2 in there instead of that 8. We'll fix it here in just a second. But do you see this? We're not going to break this all the way up. This is what we're going to be doing in our head, like what we just talked about. Right? But you were probably hollering at me, good job, you guys. Like, wait, that's an 8. That's an 8. Yes, it is an 8. So it's a good thing we looked at that, huh? 98% of success in mathematics is organization. You're going to hear that over and over from me. So pay attention to those little things because then that makes an impact. All right? Okay. So I'm going to do one more of these and then we're going to get into the real deal Holyfield of what we're actually going to be doing. If I take the limit as x approaches 2 here of 6 times f of x, g of x plus h of x, you're literally doing the same thing. I am not going to write this out as every single limit because that's ridiculous. What are we doing? We're plugging it in. I'm taking this limit as x approaches 2. F of x is represented by a 4. G of x is represented by a 5. And h of x is represented by an 8. Not a 2, but an 8. So this is equal to 6 times, oh dang, I pushed that up there and I didn't even see it. 6 times 4 times 5 plus 8. See that? So 6 times 4 times 5. I don't know. What is this? So 5 times 4 is going to be 20 times 6. So that's 120 plus 8. So 128. Remember, you don't get a calculator. So be smart when you do these calculations. You know 4 times 5 is 20. Use that. That's smart, right? Or you could come through here and you could say 6 times 5 is 30 and then take that times 4. Do things that are easy. You don't get a calculator, so use that number sense that you're given to pull this off. All right? Okay. Now, this is just setting the stage. You are not going to have problems to where they're going to give you that all the time, right? That's not a common thing that you're looking at. Now, it does happen sometimes, but that's not common of how these problems are given. Look at this example. This is common of how you're going to be using limits from here on out. The limit as x approaches 2 of 3x squared minus 4x over 5x cubed minus 36. Here it is, ladies and gentlemen. The first thing you do when you find a limit, plug it in. That's it. When you find a limit, I want to take the limit as x approaches 2. We'll plug that 2 in. Oh, yeah. Because this is really f of x, g of x, h of x, whatever the crap of x, right? Well, that's just a number. But what we're looking at is this 2 plugs in. That's it. Instead of breaking up this whole thing, literally just plug it in. Yeah, that's it. That's it. Oh, the big mystery behind a limit. You plug it in. So this is going to be 3 times 2 squared minus 4 times 2 over 5 times 2 cubed minus 36. Legit style, that is what you're doing. So 3 times 4, pardon me, is 12 minus 8 over 8 times 5 is what? 40 minus 36. So I've got 4 over 4, giving me a 1 out of that deal. That's my limit. All right? Very first thing you do is plug it in. All right? If you come up with issues once you plug it in, we'll talk about that. But very first thing you always do is plug it in. All right? Okay, let's do another example here. Here's example 4. We are going to take the limit as x approaches 2 of the square root of 2x cubed plus 9 plus a 3x minus 1 all over 4x plus 1. What? So you may look at that and be like, what is happening? This is craziness. No, it's not. You just plug that in. This is a cubed. You literally just plug it in. All right, if you want to pause the video here, plug it in, and then come back and check yourself, that's a good way to learn. So that I would suggest that. Pause, and then come back. I'm going to keep going with it. All right, so the limit as x approaches 2 here of the square root of 2 times 2 cubed plus 9 plus 3 times 2 minus 1 over 4 times 2 plus 1. Now here's the deal. When you do your limits, I shouldn't have put that in there. You write limit notation all the way up until you plug it in. As soon as you plug in this value, I'm trying to get red here. When you plug in the value, then drop the limit notation, because I'm no longer taking a limit. I'm not figuring out the limit as it approaches 2. I'm doing it, right? I'm performing that operation. A limit is an operation. When you perform the operation, you don't keep writing it, right? It's the same concept here as if I were to say the square root of 4. Once you perform the operation of the square root, you just write a 2. You don't write that operation anymore, right? This is the square root of 4 does not equal the square root of 2. You don't need that operation there anymore. Same thing with a limit. Once you perform the limit, you don't need to write it anymore. All right? That's a big deal, and I'm going to super harp on that even when we're in class, because that's a common mistake. You just write things down. Think about what it is. It's an operation. Because of that operation, once you perform the operation, you don't write it anymore. Okay, so let's rock the socks off of this. All right, 2 cubed is 8 times 2 is 16. 16 plus 9 is 25. Plus 6 minus 1 is 5. So we've got 10 on top there, right? And we've got 8 plus 1 is 9. So we've got 10 ninths. All right? Okay. All right, good. Good. Whether it's a full limit or even if it's a one-sided limit. So if we look at this one, I'm going to do one more here and then we're going to come up with something else. So here's example 5. If I have this function, f of x is a piecewise, 2x plus 4 if x is less than or equal to 1, and the square root of x minus 1 if x is greater than 1. If I'm looking at this and I want to take my limit as x approaches 1 from the right, which side am I coming from? The top or the bottom? The bottom, right? Yeah, because I'm coming from the right, where it is bigger than 1. These are the values where x is bigger than 1. So I'm going to plug this 1 in here. This is the limit as x approaches 1 that I'm looking at here from the right. Oops, that's a minus. I almost put plus. So then that will be 0, right? Because it's 1 minus 1, which is 0. And 0 is a legit answer. Don't let anybody tell you it's not. That's a legitimate answer. What if I want to come from the left? Which one am I looking at? Exactly. Because x is less than or equal to 1, so I'm going with that top one. Good. So this is the limit as x approaches 1 from the left of negative 2x plus 4. And when you plug that in, negative 2 times 1 plus 4 is 2. So your left and your right limits, right? So your left and your right limits just depends on where it is that you're coming in here. And I'm just going to show this to you so you can see. Here's our graph of that. If I'm coming in from the left, my value is 2. If I'm coming in from the right, my value here is 0. Right? Okay. Cool. Nice. And this is if it's super sweet and you plug it in and everything goes smoothly.